Okay? So what are we sketching? What are we sketching here? We're sketching the exponential. So when I grade your paper, what I will be looking for is an asymptote right here. So you have to dot that in, somehow show a dotted line there. The 0.01, and then a curve that does this. That is your exponential. That is y equals e to the x. Okay? What about the absolute value? Who remembers? That's one we just got yesterday. Who remembers what that one looks like? That's a V from the origin. So on your paper, I should see that dot right there at the origin, and then your V, shooting up with little arrows on the end. Okay? All right, and then what about the next one? What is the square root function? What does it look like? Again, that dot at the origin, and then arcing out like this. All right, any question about that? Everybody good with that? All right, then the second part says, write the name of the function. So for part 2, what function is that by name now? Logistic. That's your logistic function. Now, spelling doesn't count, but you got to be close. And that is not a hard word to spell. Logistic. What's the next one? Greatest integer. That is the one I don't like. That's the greatest integer function. Now, please notice, guys, it says write the name. Okay? On quiz day, if you can't remember the name, but you remember the equation, you can write that down for half credit. Okay, but to get full credit, you have to write the name of the function. Okay, and what's, see? Either squaring or quadratic. You don't need both of them. You can put both of them, it's no bonus points, but one or the other is fine. All right, we good with that?
Yeah.
Then you're writing the equation. So we graphed, we wrote names, now we're writing equations. So what's the equation for the first picture that's there? Y equals x. That's your linear or identity. Y equals x. What about B? ln x. That's your logarithmic. So y equals ln x. That is an L and an N. ln x. And be careful, what's C? That's your cosine. COSX. Cosine x. Now here comes the hardest one. You did 3 pictures. You did 3 names. You did 3 equations. How many BFFs are there? 12? So there's 3 that we haven't done on this quiz. So can you name the 3 that we haven't done? Now, you can write the name, write the equation, or draw the picture. I don't care. Whatever you can remember, that's what you're putting down in this thing. So, what's missing?
Sin x.
Sin x.
Y thing.
Sine is one thing that's missing.
Oh, it has an E?
Yes, the word does. Now, if you write the equation, it's sin x like this.
Okay.
And you can do either. What else? Cubing is missing. And reciprocal is missing.
Why do I have? What is it?
Logistic was the first one that they write the name of. That was logistic on number 2A. That was logistic. All right, let's try practice. The next one, which is called practice number 2.
I kind of need you like to write the logistic.
Huh?
I need you to write the logistic.
Can you draw it?
Yeah.
Okay, I will later. Not later. Okay, so here we go. Sketch the indicated curve. Ironically, Jose, that's what you need me to do, because problem 1A on practice quiz 2 is is the logistic equation. Do you recognize that? So the logistic curve, we've got asymptote here. You put an asymptote here. Guys, you gotta have two asymptotes for the logistic equation. And then we start down here and squiggle our way up like that. Jose, you can draw that.
I can't, I couldn't even see it on my paper, that's why I asked you.
Okay, well, that's what it looks like right there.
That's the 1/1 plus.
Yep, that's the logistic equation there for 1A. All right, I'm trying to do this without our note cards, guys. What does the cosine look like? Cosine, remember, is that, exactly, Megan. It's the up and down, but it's the up and down that doesn't go through the origin. So it's the up and down that starts up here and does this with arrows on both ends, and there we go. That's your cosine. So when I grade your paper, what am I looking for? I'm looking for, you start up here, right? And you go hill and valley, just like that. All right, 1/x, what's that? That's the reciprocal function, and that is the one, it too has two asymptotes, but its asymptotes go like this, right? So I gotta see those. If I don't see the asymptotes, half off. They're part of the picture. And then the curve is just framed right there in quadrant 1 and quadrant 3. That is the reciprocal function.
On tests, would you like care if we did the graphs in like pen so that you can see them?
It's fine if you want to do it in pen. It shows up better if there's any grid. Here, I don't think it matters on this kind of paper, but if I have a grid for you, yes, you can use that. Okay? So there we go. Those are our graphs. All right, write the name. So for number 2, we're writing the name. What is the name for A?
Identity.
Linear or identity, however you have learned it. Some people like to think of it as linear because its shape is a line, but it technically is the identity function. Okay, either one is fine. All right, what's B?
Square root.
Square root. That's your square root. Now remember, you are writing the name. If you can't remember the name, you can give the equation, but you only get half credit for that. But that's better than nothing. All right, and what's the name for C?
Greatest.
Greatest integer. Gotta have both words, guys. Greatest integer.
You have to?
Yes, that's the name of it. You're the greatest, Jose, so we gotta have another word on there.
That's fair.
All right, everybody okay with that? Number 3, write the equation. So now we are writing y equals something. Okay? So what do we got for that first one? What is that the picture of? That's your logarithm. So y equals ln x. What's the next one?
Y equals.
Absolute value. So y equals absolute value x.
Yeah.
Y equals 3. X3.
X to the third. The next one is your cubing function, so that's y equals x cubed. All right, now here comes the bad news. I got 9 of them up here on the board. This one was logistic. This one was cosine. And this one was reciprocal. So what is not on the board?
Sine.
Cosine's up there, but sine is not. So for part 4, the sine function. I'll write the equation, but remember, you can write the word, the name, draw the picture, or write the equation, whatever you want for this one, sine, okay? What else is missing? Titus?
Just
What? Exponential is missing. Y equals e to the x. There's no exponential on this quiz anywhere. And then there's one more missing. Squaring. So y equals x squared. Now again, for that last question, this is exactly what your quiz is gonna look like. For the last question, you may write down, I did equations this time. You can mix and match, equations, pictures, names. All right? Put the note cards away, or set them aside, just set them aside for a second, turn them over. And let's do practice F, which is the next one. See how much you can get done, take a few minutes, how much can you get done without your note cards? Let's go. Go. Practice F. Okay. Did anybody feel, did anybody get the whole page done without anything?
I need two.
Are you being serious? Good for you. That's awesome. Anybody get half of it done?
A little
A little over half, around half? Okay, then you're half ready, right? So we gotta keep studying. Let's go through and take care of this one. All right, sketch the indicated curves. To remind myself, I wrote the names up here. What does the reciprocal look like? What's, it's the one that has two asymptotes that cross each other. And then here,
Oh, you didn't know?
and
or
here.
you-
right?
Yeah.
That's your reciprocal function.
That's the first one.
That's the first one. That's what 1 over x is. That's the reciprocal. All right? Now we're gonna draw, oh no, what's this one? This is our greatest integer one. So when you graph this, guys, my beady little eyes are gonna be zeroing in on a closed dot right here. That one's closed, right there at the origin. You're gonna draw a bar and open it up.
Doesn't matter where.
Nope, and you're gonna draw your circle, draw a bar, and open it up.
How many points do you need?
Oh, is what I thought it was.
You should probably have
I knew
4 or
it was
5
right
of
there.
them drawn.
I was wondering you were. Oh, man.
So, 2 things I'm gonna be looking for. That dot, solid dot, has to be at the origin. And all of your bars should be about the same length. This isn't a grid paper, so you can't like do it on the actual grid, but make them all about the same length. Okay? Y equals absolute value x. What does that one look like?
Point in the center and the two things. that
Point
make
at
a
the
V.
origin and a V with arrows shooting up. All right, now we're writing the name of the indicated functions. Okay, what's the name of 2A? Logistic. 2B, exponential. And 2C.
Cosine. Cosine.
cosine. How do I know that's the cosine? Because it doesn't go through the origin. It's the one that starts up here, that's the cosine. All right, write the equation. Notice, I already did y equals, because the equation is an equals. So y equals something. All right, what's the first one? Y equals x, that's your identity. What's the next one? X squared, that's your squaring or quadratic. And what's the last one? ln x. That's your logarithmic function, ln x. So, look at what I got. What's missing? Cubing is missing. So
Sine.
again, you can write cubing, you can write y equals x cubed, or you can draw a picture, whatever works for you. You do not need all three, one or the other. All right, what else did you say is missing? Sine. So again, sine, y equals sine x, or my sine picture. Okay? And what's the last one that's missing? Square root. So we can write square root. We can write the equation, or we can draw the picture, whatever works best for you. All right? Okay, so, what is today, Dave? 2? So I don't see you on Thursday, but I will see you on Friday, and we will practice this one more time. And then on Monday will be our quiz. So it's do or die, folks. There's no partial credit. I mean, you know it or you don't. So let's get it learned. Okay, now put that aside. Get your notes out. And we're going to finish up 1.3 today. So 1.3 will be due on Friday. You could already do it now, but feel free to do so. But I want to do this last bit of review. So go to your notes, go to the back of page 9A. The back of page 9A. Nothing new today. We're just recapping some of the stuff that we talked about yesterday. So we are on the back of page 9A, and we are going to sketch these. Before we do that, though, guys, before we do that, let's go through, I only have room for these 4. We'll get the rest of them. But let's talk about what all these numbers do. Pay attention to where the number is, because these two numbers in the second problem, these two numbers do very different things. If the number is inside, what does it change? Sideways. And when it's -5, it's actually going to move right 5, because it's the opposite of what you think. So instead of backing up 5, it's actually going to go forward 5. What does that +1 do out there on the end of the problem? Up 1. So, I'm doing problem 2 first. I'll come back and get this one. What shape is this? That's your square root shape, which starts at the origin and goes up and out, right? Right? So I'm going to take that shape, and I'm going to move it right 5 and up 1. So now I'm at the point 5, 1, and I'm going to go up and out. There it is. Moving the shape does not change the shape. It just moves it. Adding and subtracting just moves the shape. All right, let's back up and get the first one. Is this one gonna have the exact same shape? Yes,
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 yes. This is a square root, just like this is a square root. Now, it won't be in the same place. Where will this one be? Left 2. Why is it left? Because that number is inside the problem. It's not outside the problem, it's inside the thing. So this is gonna go left 2. Notice how I always label my starting point. Just like your asymptotes, you need to label it. Label it, label it. Now, will this one be the same shape as these?
No.
No, this is not a square root, this is a square. What shape is a square? Parabola? Normally, the parabola, I'll sketch the normal one here. Normally, a parabola is up from the origin. How has this one changed? Down 2. So I'm moving it down 2, and then there it is. There's my parabola, just like every parabola, but it's down 2. Right, guys?
Yeah.
Girls? Okay, now what about this one? This one's got 2 things going on. What is this part gonna do?
Right.
Right 2? And this is gonna go up 3. Remember, it's only opposite if it's inside parentheses. If it's inside parentheses or inside the problem, it's opposite of what you think. But if it's outside, it does exactly what you think, up 3, plus 3. So this is gonna be my parabola shape, but it's going to go right 2 and up 3. So what's that point gonna be? My starting point is going to be 2, 3. And there's my parabola. There are 4 more of those at the bottom, H, I, J, and K. So let's do those right now, and then we'll start in with the piecewise functions. All right, so here we go. What's this one going to look like? What is this? This is what shape? Exponential. And the normal exponential has an asymptote right here, a dot at 0, 1, and shoots up through that dot like that. That's the normal exponential. What have I done to this?
You go up
Down.
1. Whoa.
Down.
Down.
This goes down. Down 1. So I'm gonna draw that same picture, but everything's coming down 1. So the point is actually gonna be on the origin now. And the asymptote is actually gonna be down here at -1, because it came down 1. And then I have exactly the same shape I always do, but it's down 1 from the original. You are up the creek without the proverbial paddle if you don't have your shapes learned. Gotta learn them. Gotta learn them. Okay, I, what's happening here? Pay attention to where that +2 is. See where it is? It's in the parentheses. So that means it's going to be sideways, and it's going to be opposite, so it's going to be left 2. This is going left 2. So again, think about the original. The one you have memorized has an asymptote here, a dot at 1, 0, and it comes up from the bottom and goes out like that. That is your logarithmic picture. Now what are you doing to it? You're taking every part of that picture and you're backing it up too. So your asymptote, which was here, is now gonna back up 2, so now it's right here at -2. The dot, which was at 1, it's getting backed up 2, so now it's at -1. And then there's your shape. Didn't change the shape, just changed its location. Which BFF is this? Cubing. So the normal cube, this is the one some of you have trouble drawing, the normal cube does this through the origin.
It goes over 2.
What am I doing to this? I am moving it right to. So now, when I do my squiggle that used to be at the origin, now it's gonna be at this point right here. Would you agree with that? So come up from the bottom, squiggle through, and there you go. So it's exactly the same shape. Just pretend that you could cut it out and glue it 2 over. And then the last one. What BFF is this? Square root. So you know what that means. That means it's going to start at the origin and go up and out. But what happened to this one? It went right 3 and up 4. Yep, right 3 and up 4. So here we go. 1, 2, 3. 1, 2, 3, 4. This would be the point 3, 4. And up and out, right there. All right. We got that? Easy problems if you know your shapes and you know your rules about how things move. Okay, now we're ready to do our piecewise. We did some of these yesterday. We're gonna do some more here to review, because there's one in your homework. At least one, I don't know for sure. All right, so here we go. Problem E. X squared, and we have x plus 3. Okay? All right, one step at a time. Let's do that top line. First of all, where's my break gonna be? Where's my squiggly? At 1. That's when the picture's gonna be broken. Piecewise functions are in pieces. What shape is that? Parabola. Vertex at the origin. There it is. Here's where it breaks. Open dot or closed. Closed dot. I broke it. Am I keeping the left or the right?
Right.
I'm keeping the left. So I am erasing, I'm throwing away the right. I broke my parabola. I keep a piece, I throw a piece away. What's that second one look like? What's this? It's linear. Now, the normal line goes through the origin, right?
Yeah, this goes
But
up
what have I
3.
done? I've moved it up 3, so 1, 2, 3. So this line is coming through here like this. And it got broken right there. Opened out or closed? Open. My line is broken. Which piece am I keeping?
Right.
Keeping the right, which means throw away the left. So you have, I can get rid of this line now, this crack, get rid of him. And I have a nice little half parabola there and a nice little half line there.
Why does the greatest integer function have like 2 brackets?
Why does it?
Yes.
Just a notational thing, I don't know. I don't get to make up those kinds of rules, I just have to follow them. Oh, what are these shapes? Both of them are plain X's,
Right here.
which means they're both lines. I'm gonna have 2 lines. This first one is one of the tricky ones. We talked about it yesterday. 2x, y equals 2x plus 0, if you want to think of it as mx plus b. That is a line that goes through the origin, which by the way is where my squiggly is. It goes through the origin and has a slope of 2. So up 2 over 1. So it's going to be a steeper line than normal. This blue marker's fading fast. It's a steeper line than normal. It crosses my squiggly right here, so I'm gonna put a big dot right there. Will that dot be open or closed? Open. And will I keep, I do keep the right that way. That's what I keep. So I'm gonna erase this, put an arrow on the end, and there we go. That's what I got.
On this board.
What?
Could we opt to keep the squiggly line? and-
Yep. Okay, what's this one? Another line. This one I haven't changed the slope on. What have I done to this one? Down 2. So this one is going to look like this. It's just a regular identity, but it's down 2. So there's where it's broken. Open or closed pink dot. Closed pink dot. And which part am I keeping?
Left.
Left. So I'm going to get rid of right. And that's it. So we got a little arrow shooting up this way and one shooting down this way. Getting the hang of this, guys? One more. It's a 3-parter, which doesn't mean anything. We don't do anything any differently. We just have more of it. So, y equals 3x, x plus 1, x squared, okay. Here we go.
Just said no.
We'll have 2 squigglies this time. We'll have a squiggly at 1 and a squiggly at -2. But that makes sense because it's a 3-part problem. So we're gonna have a piece on the left, a piece on the right, and a piece in the middle. Okay? All right, here we go. Pink first. Oh, here's this tricky one again. Y equals 3x plus 0. mx plus b. What is that? A line with a slope of 3. So I'm going to start here at the origin, count up 1, 2, 3, and over 1, down 2, 3, and over 1, and connect all those with a nice straight line, as straight as I can make it. Which squiggly do I care about? Notice that whole top line now, this is all pink.
-2.
The only one I care about is this one right here.
Yeah.
Open or closed?
Over.
Open. Keeping which piece? This little tiny piece right here, some of you probably can't even see it. This little tiny piece right here is what I'm keeping. I have to erase all the rest of this. All I need is this little tiny piece of that line down here. All right, what's that? Another line,
Yeah.
but it's a normal line, just moved up 1. So it's just gonna be a normal line, just like that right there. Now this is green, so which squiggly do I care about with that line? This one. So this is where it crosses. Open or closed?
Closed.
Closed. Keeping which piece of it?
Right.
So get rid of this. So far, you have got your left piece and your right piece. So now we're gonna work on the middle. All right, so what have we got in the middle? A parabola. It's vertex at the origin and opens up. Now notice, we care about both lines this time. So here we have a dot, and here we have a dot. Open or closed? Closed on the -2, but open on the 1.
Yeah.
What am I keeping? Keep in the middle. Look at that X, kids. Where's that X? In the middle. I keep in the middle. So I'm getting rid of this, and I'm getting rid of all this. If you wish, you can get rid of your squiggly lines. You don't have to. But if you think it cleans up your picture, makes it look cooler, you can take that out. And there it is. So we've got a little blue piece of parabola. We got a thing down here and an arrow up there, and that is it. One more comment, because next time we're moving on to something else. One more comment. Notice how the dots are always lined up. One solid, one open. Never matching dots, okay? All right, that's it, folks. That's it. You cannot get your phones, we're at the end of the day, so we gotta wait till prayer's over.